if they give me that the inverse, find the inverse, and they give me the function f, and these are the ordered pairs for f, then by the definition, f inverse is going to be the ordered pairs with the x and the y reverse. So instead of 4, 2, we would have 2, 4, 3, 9, 6, 36. And this would be your inverse. Number 2, which of the functions is the inverse of f of x equals x minus 4 divided by 7? So if we want to know which one of these is the inverse, and I went ahead and added a third option, then if we take the composition as stated up here, we should end up with x. Okay, so we can start with the first one. We're going to find g composed of f of x. If it's going to be an inverse, then it needs to give us x back. So here I would have g. F of x is x minus 4 divided by 7. Now I'm going to plug this into the function g. Okay, so I plugged in x minus 4 divided by 7 into this x. And now I can simplify. On the top here, I need a common denominator of 7. So in order to make this 2 have a denominator of 7, I will need to multiply the top and bottom by 7. 2 times 7 is 14, and this is all divided by 5. So in the top numerator, I can now get x minus 18 divided by 7. Minus 4 minus 14 is negative 18. And then this I can rewrite as x minus 18 of 7 times, or I'll just write it as division, divided by 5. And I'm going to come back up here. So x minus 18 divided by 7, I can change that to multiplication if I take the reciprocal of 5. So we get x minus 18 over 35. So the answer for g of f of x is equal to x minus 18 divided by 35. Since we didn't get an x, then that means that this is not an inverse of f of x. If we did get an x, then we would have to check f composed of g of x to see if that also gives us an x. Okay, so both have to give you an x, g of f of x and f of g of x. If one fails, then you can stop and say that it's not an inverse. So let's check this one, h of f of x. So I'm going to plug in f of x here, so I get h of x minus 4 over 7. And anywhere I see an x, I'm going to plug in what's in the parentheses for h. So we get 5 over x minus 4 divided by 7 plus 2. I'm going to take care of this here by dividing. So 5 divided by x minus 4 over 7 is the same as 5 times 7 over x minus 4. So we get 35 over x minus 4 plus 2. We need a common denominator. So we get 35 over x minus 4 plus x minus 4 over 2 times x minus 4. So we can see here that this is not going to be x, not equal to x. So this is not an inverse of f of x. And then the third one that I added, we have p of x is equal to 7x plus 4. So if we find the composition, let me write f of x up here so we can see it. Then here we get P of f of x, which is x minus 4 divided by 7. So anywhere I see an x for P, I'm going to substitute that value in the parentheses. So simplify here, distribute this, so we get 7x minus 28 divided by 7 plus 4. And so we need a common denominator, which is going to be 7. So in order to make this 4 a 7, have a denominator of 7, I multiply the top and bottom by 7. 4 times 7 is 28. So we can see that negative 28 plus 28 is 0, giving us 7x divided by 7. So we get x. So P of f of x gives us x. So that is good because we are supposed to get an x. However, it has to work if we reverse it. So instead of P of f of x, we also have to check f of P of x. So here I have f, P of x is 7x plus 4. So anywhere I see an x for f, I'm going to plug in 7x plus 4. So for this x, I'm going to plug in 7x plus 4 minus 4 divided by 7. So 4 minus 4 is 0. So we end up with x. So you can see here, if we reverse the order of the functions, p composed of f of x or f composed of p of x, it doesn't matter, they both give us back an x. When that happens, then we say yes, it is an inverse of f of x.